So, good morning, all of you. So, in our last lecture, we have seen related to the summer air conditioning system or working principle of summer air conditioning system, then winter air conditioning system, after that, year-round air conditioning system. And after seeing the air conditioning system, different types of or classification of different air conditioning systems, we have switched to the load calculation. So, we have seen the various parameters which we have to consider while calculation of load, that may be heating load or that may be cooling load, while designing of any of the air conditioning system. And after that, we have seen the different types of load or heat gains which are occurring inside the building. So out of that, first one is nothing but the sensible heat gain, second one is nothing but the latent heat gain. And we have seen the factors which are affecting on the sensible heat gain and which are affecting or which are contributing in the latent heat gain. So after this, we have to see the numericals based on the heating and cooling load calculation. So first numerical will take. So the statement of first numerical is an air conditioning plant. An air conditioning plant is to be designed for a small office for winter condition. So there is one small office, and we have to design the air conditioning system for the winter condition. So here they have mentioned that outdoor conditions means whatever atmospheric conditions are there. So in winter season, atmospheric conditions are 10 degrees centigrade dry bulb temperature and 8 degrees centigrade wet bulb temperature. And inside this small office, whatever required indoor conditions are there, those are nothing but 20 degrees centigrade dry bulb temperature and 60% relative humidity. And amount of air circulation in that small office, we required to have the 0.3 meter cube per minute per person. And sitting capacity of that small office is nothing but 50%. So in that small office, 50% can accommodate. So here for that small office, we have to design the air conditioning system. So the required condition is achieved. The desired condition or required condition is achieved first by heating and then by adiabatic humidifying. So here, what is the meaning of adiabatic humidifying? Adiabatic humidification means it is the process of cooling and humidification. So if you are not knowing, then write in your notebook or take this point or note down this point that adiabatic humidification means it is the process called as the cooling and humidification process, which will occur at a constant enthalpy only. So here, what we have to find out? Find the heating capacity of coil. In terms of kilowatt and surface temperature of the coil. And the heating capacity of the coil in terms of kilowatt and surface temperature of the coil if bypass factor of the coil is 0.32. Coil is 0.32. And second thing, we have to find out the capacity of humidifier. So here, for better understanding of this problem, we'll represent this problem in the line diagram. So here, as we are knowing that we have to design the air conditioning system. So for designing air conditioning system, so for having the treatment on the air, we should have the air handling unit. Suppose this is the air handling unit. So to that air handling unit, we are supplying the outdoor air. So raw air or outdoor air or atmospheric air. Suppose here to this inlet point, we are taking the outside air. So inlet point always I'm considering as a point number 1. And what is the condition of outside air? Outside air condition is nothing but 10 degrees centigrade dry bulb temperature, 8 degrees centigrade wet bulb temperature. So whatever this air is there, that air is having the dry bulb temperature as a 10 degrees centigrade and wet bulb temperature as a 8 degrees centigrade. wet bulb temperature as a 8 degree centigrade. Okay, now here the required indoor conditions are 20 degree centigrade dry bulb temperature and 60% relative humidity. That means here whatever insulated room or whatever small office is there, so to that small office, suppose this is a small office, so whenever after doing the processing on that outside air, whatever supply air will be there, that supply air will be supplied to this insulated space or this small office, and here whatever conditions I have to maintain, so this is nothing but the small office. Small office, and here whatever conditions I need to maintain, here I need to maintain the dry bulb temperature as a 20 degree centigrade, dry bulb temperature as a 20 degree centigrade, and relative humidity as a 60%. So here if I am considering required room condition as a point number 2, okay. So here how we are achieving this condition, so here amount of air circulation is nothing but 0.3 मीटर क्यूब पर मिनिट पर पर्सन, म्हणजे एका व्यक्तीसाठी किती आपण अमाउंट ऑफ एअर सर्क्युलेट करतोय, 0.3 मीटर क्यूब पर मिनिट. And what is the sitting capacity of this office? Sitting capacity of this office is nothing but 50%. So how much volume of air I need to supply? So here amount of air circulation is nothing but 0.3 meter cube per minute. 0.3 meter cube per minute per person. So if there will be the 50%, then for each person 0.3 meter cube per minute air is required. That's why for 50% here 0.3 into 50, that is nothing but, what is this value? 50 into 0.3, what is this value? So here this much amount of air meter cube per minute, 0.3 into 50, that is this much amount of air I need to supply, that is nothing but the volume of air. So volume of air which I am supplying, that is nothing but 0.3 into 50. Meter cube per minute. Now whatever desired conditions are there, the required condition is achieved first by heating and then by adiabatic humidifying. That means here first of all I am using the heating coil. So with the help of heating coil, suppose here I am using the heating coil. Suppose this as a heating coil. So whenever outside air will pass over this heating coil, here the properties of that air will goes on changing. That means outside air will goes on changing. So here after passing over that heating coil, the properties of that outside air will goes on changing. If I'm going to consider this as my point number 3, and whatever condition of heating coil is there, suppose this has my point number 4. So the required condition is achieved first by using the heating coil and then by using the adiabatic humidification. So here I am using the adiabatic humidifier. So adiabatic humidifier means here cooling and humidification process will occur. So here suppose I am using the adiabatic humidifier. In this section, I am using the adiabatic humidifier. Adiabatic humidifier. So here they have asked us find the capacity of coil in terms of kilowatt. Find the capacity of coil, that means heating coil. So heating capacity of coil. So first question they have asked us find the heating capacity of coil. So here for this coil I have to find out the capacity of heating coil. Capacity of heating coil I have to find out in terms of kilowatt. In terms of kilowatt. And surface temperature of this coil also I need to find out. What will be the surface temperature of this coil? Surface temperature of this coil I have to also find out. Then here they have mentioned that bypass factor of the coil is 0.32. So related to this coil, the bypass factor, that is nothing but x is equal to 0.32. Only that this much thing they have mentioned related to this coil. And also I have to find out the capacity of humidifier. So now if this point number 3 air will pass over this humidifier or adiabatic humidifier, the property of that air will goes on changing. That's why here whatever air is coming at the outlet of adiabatic humidifier, that point will be considered as a point number 5. That air will be considered as a point number 5, and that air will be called as a supply air condition or condition of supply air. That air will be called as a condition of supply air, and that supply air will be supplied to the small office. And after supplying that air to the small office, here after absorbing amount of heat generated, inside the small office, here required condition will be achieved. लक्षात घ्या. त्या ठिकाणी जर मला त्या ऑफिसमध्ये 20 डिग्री सेंटीग्रेड ट्रायबल टेम्परेचर आणि 60% रिलेटिव्ह ह्युमिडिटी जर अचीव करायची असेल किंवा मेंटेन करायची असेल, तर त्या एअरला जी काय आपण त्या रूमला जी काय आपण एअर सप्लाय करणार आहे, त्या सप्लाय करणाऱ्या एअरची पण कंडिशन सेम असणार नाही ॲज दॅट ऑफ रिक्वायर्ड कंडिशन. ती काय असणार आहे, डिफरंट असणार आहे. म्हणजे ह्या ठिकाणी जर मला 20 डिग्री आणि 60% रिलेटिव्ह ह्युमिडिटी जर मेंटेन करायची असेल, तर मी काय करणार आहे, ह्या स्मॉल ऑफिस मध्ये किती अमाऊंट ऑफ हीट जनरेट होते बिकॉज ऑफ वेरियस पॅरामीटर ते अगोदर कॅल्क्युलेट करणार आहे. आणि ते कॅल्क्युलेट केल्यानंतर तेवढी अमाऊंट ऑफ हीट ह्या सप्लाय एअरनं ऍब्झॉर्ब केली पाहिजे. तेवढी अमाऊंट ऑफ हीट किंवा तेवढा अमाऊंट ऑफ दॅट मे बी सेन्सिबल और लॅटेंट, तेवढी अमाऊंट ऑफ हीट ह्या सप्लाय एअरनं ऍब्झॉर्ब केली पाहिजे. आणि ती ऍब्झॉर्ब केल्यानंतर ही कंडिशन आपली मेंटेन झाली पाहिजे. म्हणजे सप्लाय एअरची आणि डिझायरेबल कंडिशन विल नॉट बी सेम. आर यू गेटिंग? So this will be the diagrammatical representation of this problem. Now here if I want to solve this problem, then how should I solve this problem? So wait for 1 minute. What I will do. Okay. Wait for 1 minute only. What I will do, I will take the psychrometric chart on the same slide. So that it will be easy for understanding purpose. Now it is possible. So now what I will do, I will locate the condition on this psychrometric chart so that it will be easy for you to understand this concept. So here I have to first of all locate the point number 1 on this chart. So point number 1 is indicating okay. I will first of all locate the point number 1. Point number 1 is indicating 10 degrees centigrade drivable temperature, 8 degrees centigrade wettable temperature. So here if you see here 10 degrees centigrade, okay, on the chart itself here, this is the 10 degrees centigrade drivable temperature. Sorry. This is the 10 degrees centigrade drivable temperature, and 8 degrees centigrade wettable temperature means this is the 5. This will be the line 6, 7, 8. So this is the 8 degrees centigrade wettable temperature. So 10 degrees centigrade drivable temperature and 8 degrees centigrade wettable temperature is intersecting at this location. So this will be my point number 1. Okay. So here 10 degrees centigrade and 8 degrees centigrade somewhere here. So this will be my point number 1. Okay. And here the condition which I need to achieve is nothing but 20 degrees centigrade drivable temperature and 60% relative humidity inside the small office. So 20 degrees centigrade drivable temperature. So this is the 20 degrees centigrade drivable temperature line, and 60% relative humidity means, so this is the line which is indicating the 60% relative humidity. So follow this line, and where this line is intersecting to the 20 degrees centigrade drivable temperature. So this will be my inlet condition, sorry, desirable condition. So this will be my final point, point number 2. So here 20 degrees centigrade is, I think, 20. So this is the 20 degrees centigrade, and I think 60% is nothing but this. So this will be my point number 2. This will be my point number 2. Now to achieve this condition, here first of all I am supplying that air over the, I am supplying this air over the heating coil, which is having the bypass factor as a 0.32. So here as I am using the heating coil, so here with the help of this heating coil only sensible heating is possible. With the help of this heating coil only sensible heating is possible. That means here from point number 1 I am going to draw the sensible heating line. From point number 1 I am going to draw the sensible heating line, but up to which point should I draw this sensible heating line, that I am not knowing. Up to which point should I draw this sensible heating line, that I am not knowing. Only I am knowing that up to point number 3. Up to point number 3 I have to draw the sensible heating line, or up to point number 3 I have to draw that sensible heating process. So here what I am going to do, as I am knowing that, sorry, here, wait for one. Here in this problem they have not mentioned the sensible or they have not calculated the amount of heat generated inside the room. They have directly asked us that the required air condition here, the required condition is achieved. The required condition is achieved first by heating. The required condition is achieved first by heating and then by adiabatic humidifying. That means they are not saying that after heating and adiabatic humidification we are getting the supply condition. No, they are saying that required condition is achieved. That means here after adiabatic humidification, I will directly get the condition number 2. I will directly get the condition number 2. In some problem, in some of the problem, they will mention that there is a generation of heat. That means they will give the sensible heat load generated inside the room and latent heat load generated inside the room. So in that case, here point number 2 and point number 5 will be separate or different. That means supply condition will be different and desirable condition will be different. But here in the problem itself, they have clearly mentioned that the required condition is achieved first by heating, and then by adiabatic humidification. That means here I will, after point number 3, I will get directly point number 2. Okay. So here this point number 5 will not be there. This point number 5 will not be there. So here, as I'm not knowing the point number 3 condition. Hello. Wait for one. Hello. Wait for 1 minute. I think I lost college network. I will connect the laptop with the help of mobile network. Wait for 1 minute only. Hello. Am I audible now? Can anyone reply me? Yes or no? Hello. Am I audible? Hello. Can anyone reply me?
Yes, sir. Yes, sir. Audible.
Okay. So as I lost college network, that's why I think there is interruption. Okay. So here, as we are knowing that 3 to 2 process is nothing but the adiabatic humidification process, and that adiabatic humidification process will only occur at a constant enthalpy or at a constant wet bulb temperature. So now what I will do, from point number 2, I will follow the constant wet bulb temperature line. I will follow the, so here, as we are knowing that after one point, here whatever 1 to 3 process is there, that 1 to 3 process is occurring because of the heating coil, and as I am using the heating coil, that's why that process will be the sensible heating process. So from point number 1, I have to draw the sensible heating process. Sensible heating process means it will occur at a constant specific humidity. That means from point number 1, I have to draw the horizontal line, but I'm not knowing the condition. Of point number 3. I'm not knowing the condition of point number 3. That means I'm not knowing the condition of the air after passing over the heating coil. But what I'm knowing that whatever 3 to 2 process or whatever 3 to 5 process is there, this 3 to 2 process is the adiabatic humidification process, and that adiabatic humidification will only occur Adiabatic humidification means cooling and humidification process, and that adiabatic humidification will only occur at a constant wet bulb temperature or at a constant enthalpy. So what I will do from point number 2, I will follow the constant wet bulb temperature line or constant enthalpy line, and where that constant wet bulb temperature line or constant enthalpy line will intersect to the sensible heating process, that will be my point number 3. That means here 1 to 3 process will be the sensible heating process, and 3 to 2 process, 3 to here 1 to 3 process will be sensible heating process which will occur inside the heating coil, and 3 to 2 process will be the cooling and humidification process or adiabatic humidification process which will occur inside the adiabatic humidifier. Are you getting? So this will be my point number 3. Now here from this point I will get the condition of air at the outlet of the heating coil, and here I am getting the temperature as a dry bulb temperature as a 27 degrees centigrade. So this is the dry bulb temperature at point number 3. So here that dry bulb temperature is a 27 degrees centigrade from psychrometric chart. So here what I have did from point number 2, I have drawn the constant wet bulb temperature line or constant enthalpy line, and this was my point number 3, and corresponding to point number 3 I got the dry bulb temperature as a 27 degrees centigrade. So here I got the condition of air at the outlet of heating coil, and that is nothing but dry bulb temperature as a 27 degrees centigrade. Okay, now what they have asked us, find the capacity of coil in terms of kilowatt and surface temperature of the coil. So here to find out the capacity of coil, to find out the capacity of the heating coil, I am going to use the formula as a capacity of coil or capacity of heating coil. Capacity of heating coil will be calculated by using the formula. What is the formula? Capacity of heating coil will be calculated by using the formula mass of air into enthalpy difference, आता एंथाल्पी डिफरन्स कोणता घ्यायचा आहे? हिटिंग कॉइलच्या इनलेट पॉइंट आणि आउटलेट पॉइंट या दोन्हीच्या मधला एंथाल्पी डिफरन्स घ्यायचा आहे. आउटलेट पॉइंट कोणता आहे? 3 आहे. इनलेट पॉइंट कोणता आहे? 1 आहे. तर 1 पॉइंटची एंथाल्पी त्या ठिकाणी मला 1 पॉइंटची एंथाल्पी मिळेल तिथं, आणि 3 पॉइंटची एंथाल्पी मला मिळेल त्या ठिकाणी. सो दिस इज द व्हॅल्यू ऑफ H3, this is the value of H1. So which value is higher? So value of H3 is higher as compared to H1. So I will take the H3 minus H1. Okay. So here from this chart I will get the value of H3 and H1. So here value of H3 and H1 I will get from this chart. So here I will get the value of H3. So this will be the value of H3, and here I think value of H3 is, this is the 40, this is the 45. So this value is nothing but 42.5 kilojoule per kg of dry air. And from point number 1 I will get the value of H1. So this is the value of H1, and here this value is equal to 25. So H1 is equal to 25. So here, as I am knowing the value of H3, as I am knowing the value of H1, only value of MA, that is mass of air, is unknown. So how to calculate the value of mass of air? So here I am knowing the volume of air which is passing through the coil, or which is passing through this apparatus. What is the volume? 0.3 into 50 meter cube per minute, which is nothing but equal to 15 meter cube per minute. 15 meter cube per minute. So as this is the volume, so mass of air will be calculated. Mass of air will be calculated by using the formula volume divided by specific volume of the entering air. Volume divided by specific volume of the entering air, and here entering air is nothing but the 0.1. So volume divided by specific volume corresponding to 0.1. Specific volume corresponding to 0.1. So here volume is equal to 15. specific volume corresponding to 0.1. Specific volume corresponding to 0.1. So I have to consider the specific volume for 0.1. So here I will get the specific volume corresponding to 0.1. So here this point number 1. This point number 1 is situated in between the specific volume of 0.80. ही जी line आहे, ही जी line दिसते तुम्हाला ती 0.80 ची आहे, and this is the line which is indicating the 0.90. ही जी line आहे, this line and this line. So this line is 0.80, this line is 0.90. So by judgment, you have to consider the value of specific volume. So here, as this point is nearer to the 0.80, so this value will be nearly equal to 0.82 or 0.83 or 0.825. So you can take anything, 0.82, 0.83 or 0.825. So small difference will be there. You, by using the psychrometric chart, you will not get the exact answer. You will not get the exact answer, or your answer will not be matched with your neighbor. There may be the 5 to 10% variation will be there, and that 5 to 10% variation will be allowed in the university exam also. Okay, so here, as I'm knowing that value of specific volume is 0.82 or 0.825 by judgment, 0.825. So here I will get the value of mass of air, and here this answer will be in terms of, this is the meter cube per minute, and this specific volume will be in terms of meter cube per kg. Here specific volume will be in terms of meter cube per kg. So whatever answer will be there, that will be mass of air will be in terms of kg per minute. Mass of air will be in terms of kg per minute, kilogram per minute. And here, by using this formula, whatever answer capacity of heating coil you are getting, so mass of air is in terms of kg per minute, and enthalpy is in terms of kilojoule per kg, kilojoule per kg of dry air. So here kg of dry air and this kg will get cancelled. So kilojoule per minute, whatever capacity you are getting, that will be in terms of kilojoule per minute. But they have asked us find out the value of capacity of heating coil in terms of kilowatt. So whatever kilojoule per minute answer you are getting, you have to convert it in terms of kilojoule per second. That will be your answer in terms of kilowatt. So that is how to find out the value of capacity. Okay, so here you will get the answer. So such type of solution will be there. First of all, we have located the point number 1, then we have located the point number 2. As we are knowing that 1, 2, 3 process is the sensible heating process, but I am not knowing the exact condition of point number 3. So what I have did, from point number 2, I have drawn the constant enthalpy line, and where that constant enthalpy line is intersecting to that sensible heating line, that is my point number 3. So here I am getting the condition of point number 3. Okay, so here corresponding to point number 1, specific volume corresponding to point 1 is 0.81 or 0.82 meter cube per kg of dry air, and as volume of the air is equal to 0.3 into 50, which is nothing but 15 meter cube per minute. So here based on this, I got the value of mass of air. So mass of air is equal to 18.52 kg per minute, 18.52 kg per minute. After that, for finding out the capacity of coil in terms of kilowatt, I'm knowing the formula. Capacity of coil is given by equation mass of air into H3 minus H1. या ठिकाणी तुम्ही H3 घ्या, H3 म्हणजेच काय झालं, H2 झालं, which is equal to H2 ची व्हॅल्यू किती आली 42.6 आणि H1 ची व्हॅल्यू किती आली आपली 24.8 किलोजूल पर केजी, and mass of air किती आहे 18.52 kg per minute. So by putting this value, I will get the capacity of cooling coil, and that capacity of cooling coil will be equal to mass of air H3 minus H1. H3 म्हणजेच काय आहे H2 आहे. Don't confuse here, because point number 2 and point number 3 are, this process is the adiabatic humidification, and that adiabatic humidification process will occur at a constant enthalpy. Okay, that is nothing but H2 is equal to H3. So here I'll get that answer in terms of kilojoule per minute, but I want that answer in terms of kilojoule per second. That is nothing but kilowatt. So divide this answer by 60. I got the answer, or I will get the answer in terms of kilowatt. So that answer is nothing but 5.5 kilowatt. So this is the heating capacity of the coil in terms of kilowatt. Are you getting up to this? Are you getting up to this? Yes or no? Write in the chat box. Have you got the problem up to this point? Yes or no? Or is there any query or any question? If you are having any query, any question, you can ask me, so that I will satisfy your, or I will try to give the answer for your query. Is there any query, any question? Kathir Sangha. Hello. Have you understood up to this point? Yes or no? Have you understood up to this point? Yes or no? The primary requirement for understanding purpose is you should attend each and every lecture, because if you are going to miss any of the lecture, your continuity will go on breaking, and once you miss any of the conceptual part, then after that you will not get related to that point. As I have told you that chapter number 4 and chapter number 5 are linking with each other. So until and unless you are not knowing the concept of psychrometric chart, or until and unless you are not knowing the various lines which are present in the psychrometric chart, as well as various psychrometric processes, as well as various psychrometric terms, you will not get anything. So if you are having still, if you are having any problem, any query, any question, you can ask me. Should I proceed further? If you are not going to ask me anything, I am not going to get whether you are getting the concept or you are not getting the concept. What should I do? Is there anyone who is active listener, or is there anyone who is attending the lecture? Okay, we'll proceed. Now after this, I have to find out the surface temperature of the heating coil. After this, I have to find out the surface temperature of heating coil. So how should I find out the surface temperature of heating coil? How should I find out the surface temperature of heating coil? So to find out the surface temperature of heating coil, they have provided us the bypass factor. To calculate the surface temperature of heating coil, they have provided us the bypass factor of heating coil. So we are knowing the bypass factor of heating coil. What is the value of bypass factor of heating coil? 0.32 is the value of bypass factor of heating coil. As this is the heating coil, and at the outlet we are getting the temperature as a 27 degree centigrade. इनलेटचं टेम्परेचर काय होतं? 10 डिग्री सेंटीग्रेड होतं. आउटसाइड एअर जी होती त्या आउटसाइड एअरचं टेम्परेचर किती होतं? ट्रायबल टेम्परेचर 10 डिग्री सेंटीग्रेड होतं. आणि ती 10 डिग्री सेंटीग्रेडची एअर हिटिंग कॉइल वरून पास केल्यानंतर आपल्याला जे काय टेम्परेचर आलेलं आहे, म्हणजे पॉईंट नंबर 3 चं जे काय टेम्परेचर आलेलं आहे, ते पॉईंट नंबर 3 चं टेम्परेचर किती आलेलं आहे? 27 डिग्री सेंटीग्रेड. म्हणजे ऑब्विसली ही जी काही हिटिंग कॉइल आहे, त्या हिटिंग कॉइलचं टेम्परेचर काय असायला पाहिजे? 27 पेक्षा जास्त असायला पाहिजे. आणि ते किती असायला पाहिजे किंवा ते किती असणार आहे, त्यासाठी त्यांनी काय दिलेलं आहे? दे हॅव प्रोव्हाइडेड अस द व्हॅल्यू ऑफ बायपास फॅक्टर. सो इफ आय विल यूज द कन्सेप्ट ऑफ बायपास फॅक्टर, so we are knowing the formula for bypass factor. So bypass factor of any of the heating or cooling coil, bypass factor of any of the heating or cooling coil is given by equation difference between, or variable temperature difference between coil and outlet. कोणतं टेम्परेचर जास्त असणार आहे? कॉइलचं टेम्परेचर जास्त असणार आहे ऍज कम्पेअर्ड टू आउटलेट टेम्परेचर. सो TD4 minus TD3 will be there. Coil and outlet, TD4 minus TD3 will be there. whereas value of TD3 is equal to 27 degrees centigrade divided by temperature difference between coil and inlet. coilचं टेम्परेचर किती आहे TD4, इनलेटचं टेम्परेचर किती आहे TD1. कोणतं टेम्परेचर जास्त असणार आहे TD4 ची व्हॅल्यू जास्त असणार आहे. सो TD4 minus TD1. So here I am knowing the value of bypass factor. What is the value of bypass factor of that heating coil? 0.32. I am knowing the value of TD3. What is the value of TD3? 27 degrees centigrade. And I am knowing the value of TD1 also. What is the value of TD1? 10 degrees centigrade. So only unknown is a TD4. So one equation, one unknown. So easily I can calculate the value of TD4. So after calculation of heating capacity of the coil in terms of kilowatt, I have to find out the surface temperature. So to find out the surface temperature, I am knowing the formula of bypass factor. So bypass factor is given by equation TD4 minus TD3 divided by TD4 minus TD1. So value of bypass factor is 0.32. TD4 is the unknown quantity. TD3 27 or 27.5. TD4 that you can 10. TD4 minus TD1 value is 10. So here by solving this equation, I will get the surface temperature of the heating coil, and surface temperature of heating coil is 35.7 degrees centigrade. Surface temperature of heating coil is 35.7 degrees centigrade. So after getting that value 35.7 degrees centigrade, what I will do, I will locate that point number 4. 35.7 degrees centigrade means this value. So here my point number 4 will be this point. I have to draw the straight line from point number 1 to 3 up to point number 4. So here point number 4 will indicate. Again, point number 4 का indicate करना है. Point number 4 will indicate the condition of heating coil. So here that condition of heating coil I am getting at a 35.7 degrees centigrade. That means here somewhere here I will get the point number 4. Okay, so this will be my point number 4. So here this will be my point number 4, and value of TD4 I have calculated. So this is the value of TD4. Now after this they have asked us, find out the capacity of humidifier also. दूसरा question type. Second question is find out the capacity of humidifier. Now where that humidification process is taking place, that adiabatic humidification process is taking place in between point number 3 and point number 2. In between point number 3 and point number 2. So here if I want to find out capacity of humidifier, what is the formula for capacity of humidifier? Can anyone tell me what is the formula for capacity of humidifier? Capacity of humidifier is given by equation mass of air into specific humidity difference. Mass of air into specific humidity difference. आता specific humidity difference कोणत्या दोन पॉइंटचा पाहिजे मला? त्या humidifier चा इनलेट पॉइंट आणि आउटलेट पॉइंट त्या दोन्ही मधला specific humidity difference पाहिजे. So here as inlet point that for that specific humidity, okay, to find out the capacity of humidifier, I am knowing the formula, that is mass of air into specific humidity difference. Specific humidity difference कशाचा पाहिजे? त्या humidifier इनलेट पॉइंट आणि आउटलेट पॉइंटचा स्पेसिफिक ह्युमिडिटी डिफरन्स पाहिजे. ह्युमिडिफायरचा इनलेट पॉइंट कोणता आहे? पॉइंट नंबर 3 आणि आउटलेट पॉइंट कोणता आहे? पॉइंट नंबर 2. तर मी ह्या ठिकाणी जर त्याची स्पेसिफिक ह्युमिडिटी जर चेक केली तर पॉइंट नंबर 3 ची स्पेसिफिक ह्युमिडिटी येते ह्या ठिकाणी. दिस विल बी माय स्पेसिफिक ह्युमिडिटी करस्पॉन्डिंग टू पॉइंट नंबर 3 and corresponding to point number 2, specific humidity corresponding to point number 2, this will be my specific humidity corresponding to point number 2. So as point number 2 is having higher specific humidity as compared to point number 3, that's why whatever formula will be there, my formula will be small w2 minus small w3. W2 specific humidity at point number 2 minus specific humidity at point number 3. W2 minus W3. Mass of air into W2 minus W3. So here, by using psychrometric chart, I will get the value of small w2 and small w3. So value of small w2 is equal to in between 0.08 and 0.09. आणि W3 ची value आहे in between 0.05 and 0.06. So exact value we will see. So to find out the value of capacity of humidifier, formula is mass of air into specific humidity difference between point number 2 and point number 3. आता या ठिकाणी point number 2 आणि point number 3 घ्या किंवा 1 घ्या किंवा 4 घ्या किंवा का कारण की point number 1, point number 3 and point number 4 is having the same value of specific humidity. Actually formula is W2 minus W3. पण W3 म्हणजेच काय या ठिकाणी W1 आहे किंवा that is nothing but equal to W4 आहे. So here I can take W1, W2, sorry, I can take W2 minus W3 or I can take W2 minus W1 because point number 1, 3 and 4 are having the same value of specific humidity. So here if I will check the value of small w1 is equal to 0.0058 kg per kg of dry air and value of w2 small w2 is equal to 0.0088 kg per kg of dry air. So if I will put this value in this equation, already I am knowing the value of mass of air. So mass of air is equal to 18.52. So after putting these values, mass of air, I got the value of mass of air in terms of kg per minute. And here whatever specific humidity difference is there, that is in terms of kg per kg of dry air. So here kg and this kg of dry air will get cancelled and I will get the answer in terms of kg per minute. So here by putting these values, I will get the value of capacity of humidifier. That capacity of humidifier is nothing but 0.055 kg per minute. म्हणजे तो humidifier किती kg of water vapor add करतोय per minute inside that air. So that humidifier is having the capacity. That capacity of humidifier is also known as the amount of water vapor added per minute. So here capacity किती आहे त्या humidifier ची? That humidifier can add 0.055 kg of water vapor. 0.055 kg of water vapor per minute. So that is the capacity of that humidifier. So this is the solution for this problem. Are you getting? Yes or no? Are you getting how to solve the problem? Yes or no? Can anyone reply? If you are having any question,
full sorry, full झाल्यावर पांढरी लो झाल्यावर किसरी दाखवते.
अक्षय कांसरे. Okay. If you are having any query, any question, you can ask me related to this problem or related to this chapter also. Is there any concept or is there any point which you haven't understood? Okay. In the same fashion, we'll solve the another problem also. So time is 11:55. Okay. I will show the problem. The following data refer to an air conditioning of public hall. The following data refer to an air conditioning of public hall. Outdoor conditions are 40 degrees centigrade dry bulb temperature, 20 degrees centigrade wet bulb temperature. Required comfort conditions are 20 degrees centigrade dry bulb temperature, 50% relative humidity. The seating capacity of the hall is 1000%, and amount of outdoor air supplied is nothing but 0.3 meter cube per minute per person. Okay. If the required condition is achieved, त्या ठिकाणी पण डायरेक्टली सांगितलंय रिक्वायर्ड कंडिशन कशी अचीव करतोय आपण? फर्स्ट बाय एडियाबॅटिक ह्युमिडिफिकेशन. एडियाबॅटिक ह्युमिडिफिकेशन म्हणजे कोणती झाली प्रोसेस? कूलिंग आणि ह्युमिडिफिकेशन प्रोसेस. adiabatic humidification, and then by cooling, then find the capacity of cooling coil and surface temperature of coil, and the capacity of cooling coil and surface temperature of coil if the bypass factor of coil is 0.25. If the bypass factor of coil is 0.25. And second thing, find the capacity of humidifier and its efficiency. And the capacity of humidifier and its efficiency. आता efficiency calculate करायचे म्हणजे काय calculate करावं लागणार आहे तुम्हाला? First of all, you need to calculate the bypass factor, and 1 minus efficiency, or 1 minus bypass factor is nothing but the efficiency. Okay, so today I'm going to take the another lecture, second lecture also, in the afternoon session or evening session. That means in the middle session or in the last session. So now what you have to do, you have to take the screenshot of this slide in your mobile. Take the screenshot of this slide in your mobile. Already I have provided the psychrometric chart on our group. So by using the psychrometric chart and by using the problem statement, you have to try to solve the problem. So until and unless you are not going to try to solve the problem at your own, you will not get where you are getting stuck up, or you are not getting the or you are not get where which point you haven't understood. So you may get 1 hour, 2 hours in between our this lecture and next lecture. So also you are having 1 hour lunch break also. So up to our next lecture may be at 2 o'clock or maybe at 3:30 o'clock, depending upon the adjustment of remaining faculty, or Mangekar sir and Gidde sir. Okay, so up to that time you have to try to solve this problem, and you have to note down where you are getting stuck up, and if you are if you are able to solve the problem, then well and good. Okay, so take the screenshot of this question, or take the screenshot of this PPT or this slide, so that you will be able to solve the problem. Okay, as time is 11:58, I will take the attendance. In between, you have to take the screenshot. Today's date 29 December. Okay. Roll number 1 to 7 absent. Roll number 8 present, 9 absent. 10, 11, 12, 13, 14 absent. 15 present, 16 present. 17, 18, 19, 20 absent. 21 present. 22, 23, 22, 23 absent. 24 present. 25 absent. 26 absent. 27 present. 28 present. Then 29, 30, 31, 32, 33 absent, 34 present, 35 present, 36, 37, 38, 39, roll number 40, 41 absent, 42 present, 43 present, 44 present, 45 present, 46 present, 47 present, 48 absent, 49 absent, 50 present, 51 present, 52 absent, 53 present, 54 absent, 55 present, 56, 57 absent, 58 present, 59, roll number 60 absent, 61 present, 2 present, 3 present, 4 present, 5 present, 66 absent, 67 present, 68 absent, 69 absent, 70 absent, 71 present, 72 present, then 73, 74, 75, 76 absent. Is there anyone whose roll call whose roll number I have marked as absent? If not, you can exit the lecture. Thank you for attending the lecture. Thank you. Try to solve the problem up to next lecture.